Okay, let's go ahead and do Algebra 2. This is page 592, lesson 84, solving rational expressions. So in continuation, we've learned a lot of different ways to solve for x, finding the roots, finding the real numbers. Here we're going to solve for each and every one of these. For example 1, this is a key thing for math. Whenever you have two fractions that are set equal to each other, you think of cross multiplication. I don't know why I forgot the name. Cross multiplication. So you multiply across, so 30 times x minus 5, you set it equal to x squared minus 25 times 3. I always put the number in front of the binomial. Again, we're not trying to factor, we're just trying to simplify. So here x squared minus 25, that is a difference of two squares, but again, we're just trying to solve for x, so we're trying to go down the line further and further. So now let's go ahead and use distributive property. So this will be 30x minus 180. Then here we go ahead and distribute the 3 as well. 3x squared minus 75. We want everything on one side because we're solving for x. So we're going to add 180 on this side, and you can only add it to the 75 here. We're going to subtract 30x to both sides. I'm going to subtract it. I can't subtract it with this. I'm just going to put it over here. So then this cancels out. I just do two things at once. It's a lot easier, especially when you get higher in math. Now we go ahead and simplify. I have 3x squared minus 30x. Make sure you put it in descending order. And then negative 75 plus 80, I get 25. Nope, I get 75. So then you go ahead and you subtract each of them. You get them all together on one side. When you do that, we have 3x squared minus 30x plus 75. From this, everything's all together. It's equal to 0. Now we can go ahead and factor. So here we can factor out a3. When we factor out a3, we get x squared minus 10x plus 25. Factors of c that equal b, you have 3 times x minus 5 times x minus 5. It's x minus 5 squared. So it's the same answer. It's set equal to 0, so you set each of them equal to 0. Remember, 3 equals 0. This is now a term. You cannot have that equal to 0. X minus 5 equals 0. It's going to be x is equal to 5. And it's the same thing. So you have two answers of x minus 5, or x equals 5. But again, it's just one answer. It's x equals 5. Now for this, what they want you to do is they want you to check for a solution. So see if it's an actual solution or not. This is where you have to check your work. If I were to plug in 5 in place of my equation, my original equation here, so 30 over 5 squared minus 25, which is equal to 3 over 5 minus 5. If I go ahead and simplify that, I get 30 over 0 equals 3 over 0. 5 squared is 25. 25 minus 25 gives me that 0. So I have 30 over 0 equals 3 over 0. Remember, you cannot have zeros in the denominator. In this case here, there is no solution. So be careful of just saying, oh, this is the answer, this is good enough, it works. Not all the timing. So in this case, it does not work. Here, B, we have the same thing. Two fractions, set them equal to each other. You're going to cross multiply them to solve for it. So to cross multiply, I get 9 times x minus 5. Is that equal to x times 5 minus x? I always put the x in front of the binomial. Go ahead and distribute. 9x minus 45 is equal to 5x minus x squared. Then I move everything to one side. I'm just going to move everything on this side. I'm going to add 45. I'm going to subtract 9x. And to put everything in descending order, so x squared is first, but it's negative. Keep in mind that. 5 minus 9x, negative 4x, and the 45 in the end. Then you go ahead and factor. They didn't factor out the negative, but that was a rule before. I'm going to go ahead and continue with that rule. So the rule is you factor out the negative. The first term can never be a negative. When I factor out the negative, I get x squared plus 4x minus 45. So now we have to find factors of 45 that equal positive 4. That will be x plus 9, and then x minus 5 is negative 45. 9 minus 5 is positive 4. So therefore you have your two answers here. And then you set each of these equal to 0. So negative 1 equals 0. This is not a factor. Negative 1 does not equal 0. X plus 9 equals 0. That will give you x equals negative 9. X minus 5 equals 0. This will give you x equals 5. Positive 5. So I just skip the step of setting it equal to each other. I just think of opposite signs. Positive 9, because you're going to have to move to the other side. It's going to be negative 9, negative 5, opposite sign, positive 5. Now we have to check our work. So let's say for x is equal to negative 9. We're going to go ahead and solve for that one first. We use the first equation. 9 over 5 minus negative 9 is equal to negative 9 over negative 9 minus 5. So this will be 9 over 5 plus 9, which is 14. Negative 9 over negative 9 minus 5, that's negative 14. This will just end up being as negative 9 over 14. The two negatives come out as a positive. So this works out. Let's try x is equal to positive 5. So 9 over 5 minus 5, I already see the big error there, which is having a 0 in the denominator. So 5 minus 5, I get 9 over 0 equal to 5 over 0. This does not work, so x equals 5 does not work. There's only one answer there. So you have to double check your work and see. Again, it's very easy as just plugging it in or eyeballing it and seeing if it works out. Example 2. Here is where we have different factors and we have different ways of multiplying it out. Let's go ahead and solve for this one. There's two ways you can do this. You can put 15 as a fraction, put it over 1, and then cross multiply. Or you can just multiply both sides by the common denominator. The common denominator is x minus 9. So if I multiply both sides by the common denominator, this cancels out this, and this gives me 10x. And then here, all I have to do is multiply x minus 9 on that side. The book has it differently. I don't know why the book was making mistakes for A and B. It was giving you one thing, and then magically for B, the x appeared. Or for this one, 5 turned into 10x. There's no way that can happen. Math is all about reasoning. So this is what that was what the question is. Now here we have 10x is equal to 15 times x minus 9. We already cancel out denominators. We go ahead and just factor like normal. 15x minus 15 times 9, I get 135. I get the x's by itself. I could move this over here and move this over here, but it's going to be a lot of work, so I'm just going to go ahead and move this over here. Again, you're solving from x at this point, so it doesn't matter where you move it around. So you divide both sides by negative 5, and you end up with x's being equal to 27. You can check the work to see if it works. In this case, it does, just for the sake of time. B, 8 over x plus 2 is equal to x. It says equal to 2, but that's not correct. It's actually equal to x. So now we have to find the common denominator. This is not fractions. To find a common denominator, you look at it, and it's x. So what you do is you multiply every factor by the common denominator. So if I were to show you, I have x times 8 over x plus x times 2 equals x times x. You're multiplying x to each one of these terms. You have to multiply the whole equation by it. So x times 8 over x, this cancels out, you get 8. X times 2 is 2x. X times x is x squared. And then after that, I moved everything on this side. I wanted the x to be positive. So subtract by 8, subtract by 2x. And then I get it equal to 0 because you are solving for x. I get x squared minus 2x minus 8 and set it equal to 0. And from this point, you factor. You factor factors of negative 8 that equal negative 2. And that will be negative 4 and positive 2. Negative 4 times 2 gives you negative 8. Negative 4 plus 2 gives you negative 2. And now, set them equal to 0 and then solve for them. So x minus 4 equals 0, you're going to get x is being equal to 4. X plus 2 equals 0, this will give you x equals to negative 2. Again, set up equal to 0. And those are your two solutions, and they both end up working as well. So just double check it if you want to. But here says both the original equations, true, the solutions are blah, blah, blah. Last one, here we have this sort of an equation. Here we have to think of like what we did with rational expressions, adding or subtracting. But I don't like fractions. I hate dealing with fractions. I want to get rid of the denominator just like I did in this step over here. To do that, I go ahead and find the common denominator. I can go ahead and factor first before I do that. So I'm going to go ahead and factor this. So x plus 5 over x plus 3, that's already as simplified as I can get. 28, I can't simplify that anymore. But here I can simplify that. So factors of 15 that equal 8 is x plus 3 and x plus 5. And set this equal to 4. If we look at the denominators for these three factors, these three terms, we have a common denominator, the least common denominator of x plus 3 times x plus 5. So that means you're going to multiply every term here by that. X plus 3 times x plus 5. X plus 3 times x plus 5. You're going to multiply all of it by the common denominator. And this goes back to the rule of the least common denominator. With binomials, just multiply it together. So we have one x plus 3, and we're going to multiply it by another x plus 5. Now let's go ahead and look at this side here. This already has an x plus 3, so we just have to do x plus 5 times x plus 5, or just do x plus 5 squared. We have to solve for that, but I'm not going to do that just yet. Plus 28, these are already, that's already the common denominator, so I don't have to do anything else other than that. I just end up with a 28 by itself. Here, I have 4 times x plus 3 times x plus 5. I can go ahead and multiply it out. I already know that these two factors, when I undo it, I get the x squared plus 8x plus 15, because this is what I got from factoring into this. So I don't have to do that much work. So I'm going to have 4 times whatever that is equal to. X plus 5 squared. You're going to go ahead and solve for that, so we want to simplify even more. So x plus 5 times x plus 5. So again, it's not x squared plus 5 squared. I always do it as the first term squared minus, so x5 plus x 5x plus 5x plus 25. I have another way, it's just x squared plus double of 5, which is 10x, excuse me, plus the v squared, which is 25. Here. Then you add the 28 to it, which is equal to this. And from this step here, I'm going to go ahead and use FOIL for it. So just working step at a time, get rid of denominators. Here I'm going to simplify as much as I can. Go ahead and undo that. I got this. Go ahead and factor that out. I end up with 4x squared plus 32x plus 60. Now, I'm moving everything on one side. I'm moving the x squared to the side. I'm moving the 10x to the side. Make sure you're doing opposite signs too. 25 plus 28, I got 53. So plus 53. I'm going to go ahead and subtract 53 to both sides. So I didn't show you that step. I just kind of skipped it. I just want to get through this here. So 25 plus 28 is 53. Subtract 53 to both sides. And now this side is equal to 0. So 4 minus 1 is 3x squared. 32 minus 10 is plus 22x. And then 60 minus 53, I get plus 7. Now looking at this, they're saying, hey, you can use quadratic formula to solve for this. I found another way. I found the way of factoring by the trial and error. So look at A and C, multiply it together, and see if you get factors of B. So in this case here, (32 minus 10 is plus 22). Look for factors of 3 and 7 that equal 22. 3 times 7, when you multiply it, is 21. And factors of 21 that equal 22 is 21 times 1. So in this case, it works out. I was just making sure the numbers were correct. There was no negatives or positive. Now, we have it here. We can go ahead and bring the first term down. Bring the last term down. So we have 3x squared. We have plus 7. And these two will now be our middle numbers. So I'm going to put just the 1x over here on this side and the 21x on this side. It doesn't matter where you put it. It's going to leave it like that. You can leave it as that here too. You factor the first two, factor the second two, I get x. I can't factor out the 3. I get 3x x plus 1 on one side. Here, for these terms, I can factor out a7, and I end up with 3x plus 1. So I go ahead and factor out the common factor, which is 3x plus 1 plus 7, and I get x plus 7 here. And then I go ahead and factor even more. I get 3x plus 1 equals 0. So again, negative 1/3. Here I'm going to have negative 7.